Okay. So, as we discuss about the prosodic modeling, the Fujisaki modeling, we have tried it for Bangla language long back 2010. We have published a paper on Bengali F0 contour modeling based on Fujisaki model in Contd 2010, and based on that I just present you a one slides where I show you this is the original speech. If you listen that, if you listen it Bengali, if you do not know Bengali, then just try to listen the naturalness.
তখন দেখি পুতলি পথের মাঝে থমকে দাঁড়িয়ে আছে।
So, there is a Bengali words, Bengali sentences which contain that তখন দেখি পুতলি পথের মাঝে থমকে দাঁড়িয়ে আছে. So, that sentence is the original sentence. So, I am playing the original sentence. Then what we have done, we have tried to find out whether that our generation contour, that analysis by synthesis model is correct or not. What we have done, we have extracted the F0 contour which is represented by that black spot. Here there is a black mark is there. So, those represented the original F0 contour. Okay. And if you see, there is a blue line. Once I put the phrase command, then the blue line is come, which is the phrase command. And if you see the black line, straight line is the baseline, and after putting the action command, you see the red line is generated. So, this red line is actually synthesized F0 contour. If I synthesize F0 contour is embedded on the original speech, if you see how the synthesis speech is like this.
তখন দেখি পুতলি পথের মাঝে থমকে দাঁড়িয়ে আছে।
So, there is no difference between the synthesized contour and the original contour. So, I can say that quality wise that it is possible to analyze and then synthesize using the F0 modeling. So, this we have tried for Bengali in many regions, and then what we have done that we have developed a Bengali TTS system based on that HTS model, and then try to do the F0 modification using Fujisaki model. So, I will describe that things in these lectures, because that will open up some research initiative on your own language. Now, if we see, depending on that prosodic model, Fujisaki has defined certain prosodic term of you can say the prosodic unit definition. This is basically taken from the Fujisaki definition. He said the written words and the spoken words are different, because as I said already that in spontaneous speech or in a spoken language there is no specific word boundary. Means if there is a word, there is a sentence, there is a sentence I am or I will go to Calcutta tomorrow. So, you see that every I, then there is a gap, then there is a am, then there is a gap. So, in written language this gap identified that word boundary. Okay. But in case of spoken language, if I say I am, then there is no gap between I and am. There is a co-articulation effect of I and am. So, I cannot say this boundary exists in spoken language, but yes, there is a certain word boundary exists in written spoken language which is identifiable by perception. If you see, if I perceive the original speech of Bengali sound this one,
তখন দেখি পুতলি পথের মাঝে থমকে দাঁড়িয়ে আছে।
if you see that boundary are clearly indicated, but it is not as per the lexical word boundary. Okay. So, then Professor Fujisaki defined that prosodic unit. First one is called prosodic word. So, instead of written words, we say prosodic word is defined as a part of whole of an utterance that form an accent type. If you see here, one accent type, if you see তখন দেখি is from one accent type. So, up to that this second end of this তখন দেখি is one word which is called PW1, prosodic word 1. Second accent type, third accent type তখন দেখি পুতলি is PW2, পথের মাঝে one accent type, then থমকে দাঁড়িয়ে থমকে one accent type, দাঁড়িয়ে আছে is another accent type. So, he defined the prosodic word is defined as a part of whole utterance that from an accent type is called prosodic word. In Bengali we found that every accent or every prosodic word begin with a negative accent. If we said that Bengali is a bound phrase language, that means at the beginning of every prosodic word, F0 contour is rising. If you see the F0 contour in black line, beginning of every prosodic word, F0 contour is rising. Okay? So, it is not that prosodic word is consist of a single written word. It may be several written word may be form a prosodic word. Okay? So, prosodic word is defined in spoken language, not as per the written language. So, one accent type is defined as a prosodic word. Then he defined the prosodic phrase is defined as an interval between the two successive prosodic phrase command. If you see this one, this blue line up to here, up to this line is a single phrase 1. So, this is the phrase 1. So, this is called phrase prosodic phrase. Then this is the second part blue line phrase 2, prosodic phrase 2, and last one is prosodic phrase 3. So, every phrase command is the beginning of the phrase. So, this phrase command is end of the first phrase and beginning of the second phrase. Okay. So, if you see actual boundary may be leading, that means see that here is an muscle control things. So, the effect will, the command is executed, then effect will come after certain time interval. That is why if the actual F0 rising is here, command may be executed in here. Okay. It takes some time to reach this effect. So, that is why if you see it may be some leading time. Okay. So, this is called prosodic phrase. Then he defined prosodic clause and prosodic utterances. Okay. Now, if I as per this definition, if I just draw the prosodic utterance structures, suppose this is in prosodic utterance, তখন দেখি পুতলি পথের মাঝে থমকে দাঁড়িয়ে আছে is in prosodic utterance, then I can say if I draw the rough syntactic tree of this sentence, which is nothing but a depending on the verb, the how far is the distance, then if you see the prosodic word PW is defined like this, তখন দেখি is a prosodic word. So, there is some mistake. So, PW তখন দেখি is a prosodic word, PW will be connected, this will be connected. So, this is a single prosodic word, তখন দেখি. So, there is a mistake, this gap will be not there. Then, putli, second prosodic word, পথের মাঝে third prosodic word, থমকে fourth prosodic word, দাঁড়িয়ে আছে fifth one, if you see fifth one. Okay. So, those are the prosodic words. So, there is a mistake in here, this will be one prosodic word. Then, prosodic phrase, it may coincide with prosodic word, but there is a prosodic phrase. Okay. So, this prosodic phrase is defined like again by that phrase command and then prosodic clause. So, this is called prosodic structure, which may differ, it may not coincide with one to one corresponding to the syntactic structures. Okay. So, based on this idea, when we develop the HTS engine, I am not discussing this slide, I already said again. So, when we developing our Bengali HTS TTS, what we have done, first we find out that okay, develop the Bengali HTS. Then if you see this is this blue line is indicate that original F0, red line is indicate the HMM synthesize, means without doing any F0 modification, I have trained the HTS system and I have synthesized a sentence. Then red line is that synthesized sentence F0 contour. Okay. And if you see solid line is the original boundary, dotted line is the HMM picked word boundary. Those are the word boundary. So, there is a, I am not showing that phoneme alignment, every phoneme alignment I can show. So, that phoneme alignment I am not showing here. If you listen the original speech,
আপনার বাক্সে কোনো মূল্যবান জিনিস ছিল কি?
if you see the just HTS after training I generate the sentence.
আপনার বাক্সে কোনো মূল্যবান জিনিস ছিল কি?
Then we thought, why not we train this HTS same system, instead of labeling at syntactic or written word boundary, I should train it with the prosodic words, prosodic structures. So, spoken corpora is labeled instead of syntactic structure. So, word boundary are all boundary are marked, this is the word is based on the prosodic word, based on the prosodic phrase and based on the prosodic clause. Then we see that is the word, the error rate is reduced. So, result is there in the paper. If you see that there is a journal paper on HMM based Bengali speech synthesis system, based on that paper is there. Just you can search that paper, or you can say the Bengali HTS based treatise, that our paper will come, you can read that paper. But if you see, our proposal is like that way, that we take the input text which is label, input text, and that is the speech which is label based on the prosodic structure instead of syntactic structure. Okay. Then we have done this thing, that HTS part. Then we said, since F0, if you see the HTS engine is nothing but a decoder, one is called segmental information, another is called supra-segmental information, which is nothing but a F0. So, what we said, we extract that F0 contour from HMM TTS and modify as per the language requirement. So, F0 contour which is generated by train HTS system is nothing but a F0 contour which is best matched based on the HMM modeling, but that may not be coincide with the required F0 contour, targeted F0 contour which is detected or which is defined by the structure of the sentence or syntactic structures of the sentence. So, what we done? We developed a F0 contour modeling based on Fujisaki model, and another one we have tried with the DBN network, DBN DNN methods. So, that method also we try. So, based on that we modify the F0. So, this F0 is come, and from that input text we analyze the prosodic word and prosodic phrase, and then we modify, we generate the F0 contour and supply to the decoder. So, F0 is modified. So, duration information and that segmental information is come from the syntactic you can say HTS engine. So, we are not doing anything on the duration and syntactic. So, duration is based on the prosodic structure training whatever we get using HMM modeling, but F0 is modified based on the two model. We have done this work, and I can show you this is the prosodic structure, I am not detailed discussion. So, I will show you that there is a two kind of modeling we have done. One is called Fujisaki F0 generation process model, another is called deep belief network based. Because what the problem is, Fujisaki is that Fujisaki model is successful model and it is a generation process model. So, it is very good, but only problem in this model, this requires a lot of label data to find out the rule for that generation process model. Okay. If this kind of sentence comes, this is the structure of the sentence, then based on that structure I have to form the rule, what should be the height of the action command, phrase command, all kind of things I have to define. So, that requires some label data for training, but DNN required unsupervised, DBN is learned in unsupervised fashion, it not that much of label data is required. So, it tried with that also. I will show you the result in the end. Then F0 model, Fujisaki generation process model, we have done it. So, what I have already explained, that spectrum information and duration information we training from the HTS engine, and we extract that F0 contour and modify the F0 contour based on the action command or phrase command by the Fujisaki model, and then we synthesize the speech. So, in that case Fujisaki generation process model, so action component and phrase component rule has to be generated. So, what is there, you know that if this is the Fujisaki equation, you see the phrase component, this is the action component. So, phrase component magnitude and phrase lead time, if the original phrase boundary is here where it is started. So, that that lead time is required. Okay. So, that lead time and then phrase action command magnitude and action command lead and lag time, what is the action command. So, if you see in here issue, there is a phrase command, there is a timing, occurrence of the phrase command timing, And if you see the action command, there is a beginning and end, command beginning and command end. So, we generate some rule for that, on some paper is published based on that, and then we generate those rule using that Fujisaki model, and using those rule we synthesize that, generate the F0 contour. So, then we synthesize the speech. I will show you the result in later on. And DBN, instead of Fujisaki generation process model, we try to find out that F0 contour modeling using deep neural network training. So, I am not going details on DBN, because DBN is the topic, deep neural network is a topic in recent days. So, I am not going details of the deep neural network training and all kinds of things. You can go through the paper, because that is not also that much required for this course. So, I am not going that. So, if you see that we have done, and if you see the result, this is the result, this is the original sentence.
আপনার বাক্সে কোনো মূল্যবান জিনিস ছিল কি?
This is the baseline, means where only HTS is trained based on the prosodic structures, not syntactic structure, prosodic structure.
আপনার বাক্সে কোনো মূল্যবান জিনিস ছিল কি?
Okay. Now, I modify the F0 based on the sentence structure using Fujisaki model.
আপনার বাক্সে কোনো মূল্যবান জিনিস ছিল কি?
Now, based on the DBN.
আপনার বাক্সে কোনো মূল্যবান জিনিস ছিল কি?
Both of the cases, it is shown that Fujisaki model and DBN is almost same result is found, but Fujisaki model is generalized model. So, even if there is a success rate is high, for even if the sentence type is completely unknown for this trainings that DBN. So, in that case also, because the rule is exists, so it is better, but both models are comparable, and this is already published paper. So, you can try on your own language using Fujisaki model. So, what I said that 2 USP in here we have done. One is called train the HTS engine with prosodic structures and modify the F0 contour based on the Fujisaki model or DNN model. So, if you remember, I have explained another application, that action conversion. So, my proposal is that can I not modify the F0 contour and segmental information based on that target language accent using some DNN or deep neural network or some rule based method. So, we have not yet done that, we have started that work. So, it is possible that action conversion can be done using the, because it is after all HTS synthesis is nothing but a vocoder. So, using the same principle we can do the action conversion. So, doing that research on this area. Okay. So, this is the end of that prosodic modeling using Fujisaki model. If you have a specific query, or if you are interested to pursue the research work in your own language, then you contact me. I'll give you whatever help is possible for me, I can give you the help. And I think most of the Indian language, that there is a lot of TTS is available in Indian language, but yes, there is a problem in prosody modeling, because prosody modeling not only require that generation of the F0 model, but also language analysis is very important parameter, because if you see in this research also include that partial speech tagging and all kinds of things are there, because until unless you find out, because the TTS input is only the text. So, I do not know the F0 contour. So, from the text I have to generate the F0 contour. Yes, I can take some training from some sentences, but if you see the syntactic structures of the depending on the sentence, specific prosody can be given. So, that kind of things is required, because I have to you can say that I can parameterize that synthesize or you can say target F0 contour based on some correlation between the linguistic parameters and acoustics parameter has to be trained. So, that requires that extraction of that linguistic parameter is very important. So, I have to extract those linguistic parameters. Which parameter has a correlation with the F0 contour, I have to find out. That is well established. You can see that the syntactic structures of the sentence is important, and if you see that pause modeling although in HTS engine cases pause modeling is not separate, it is within the training there, but yes, we can definitely train the system better way if we know when the pause will occur, how the pause is related with syntactic structure. So, that information can be incorporated in HTS training and that can generate better result. Okay. So, this is the last lecture in prosody modeling. So, this will be the my last lecture in speech this course, but after reviewing all the lectures whatever I have given in this things up to 7th week, you can say those are related to or up to 6th week is related to signal processing. So, only one things I have missed, which is called GMM, Gaussian mixture modeling, I have not covered, but yes, I will cover one lecture I may uploaded on GMM, the basic GMM Gaussian mixture modeling. Vector quantization I have touched upon, but I have not detailed. As I beginning I said, this course is not contain that AI part or soft computing part. I am purely concentrated on signal processing part, and see the only the not signal processing. Last 2 weeks I said something about that modern application in speech research, which can you taken care and we can pursue that speech research, or you can so that you can technology is developed. So, that is why I touches the prosody modeling as an important issue today. So, you know that that there is a the international conference on only prosody, speech prosody. Okay. So, speech prosody, there is prosody modeling, action conversion and emotion is nothing but a part of a prosody. So, emotion recognition, emotion synthesis, all are nothing but a prosody modeling. So, if you know the prosody modeling, then work on emotion area will be very easy. Okay. So, that is why I touches the prosody modeling part. Yes, I can include 1 or 2 lectures on GMM, so that it can give you some overview what is Gaussian mixture model, why we have used that, and that HMM I have said that HMM is nothing but AI algorithm. You can find a lot of lectures on HMM modeling. If you want, then I can float the, if you require a particular query, if you have a particular query, you can directly contact me, so that I can explain that things whatever I know. Okay? Thank you very much.